चलो अच्छा है यार, आयुष के सेशन के बाद थोड़ा तो एनर्जी होना चाहिए यार. Okay. So yeah, my name is Vishal. I have Anand with me, and we'll be speaking about engineering intelligence using engineering metrics. Whenever the slides are up, I'll be okay with it. But yeah, before we go there, anyone uses engineering intelligence? Offices में, projects पे.
Any engineering metrics?
Any engineering metrics? Velocity? हाथ ऊपर करो. How many of you use velocity? Very good. How many of you use defect density? You do? Okay.
Code coverage?
Code coverage, okay. Cycle time? हाँ हाँ, आयुष ने बात किया तो cycle की. Okay. जो पहले दो हमने बोले थे about the velocity and defect density, don't use that. लेकिन वो बाद में बात करेंगे, okay? But yeah, what we are going to speak about is how do you bring in engineering intelligence, which is primarily something that we have seen a lot of teams lack. That does not mean that you don't have it. It simply means that it's probably overlooked, and that's what we are going to speak about. All right? 20 minutes. Pay attention to us. We will take questions at the end. जो question पूछेगा उसको chocolates मिलेंगे.
Booth पे.
Booth पे. Anand.
Cool. Special thanks to our ex-colleague, Suneet Parikh. The talk that we are going to deliver today is heavily inspired by the e-book that he has published. Here's the QR code if you want to scan. It has much more details than what we are going to talk about.
If you need time to scan, just tell us, and then we'll move on. No? बाद में. Okay, we can go to the next slide, please. Okay, so I'm going to speak about a few challenges that engineering teams face. What I would like from you is that every time I speak about a challenge, if you face this challenge, raise your hands, good enough, all right? The first challenge that we have is tolerance towards standards. Do we all understand what standards mean? Quality? Quality is fine. What is good quality, if anyone knows? In my definition, good quality is the standard that you tolerate. So if you drive a Maruti, if you tolerate that kind of standard, then that is your quality. If you drive a Mercedes, if that is your tolerance, that is your standard. What happens in engineering is, when there's business pressure, or when there's some lack of skills, your standards might reduce, which leads to substandard products. It's essentially you're talking about quality. That's usually one challenge that many engineering teams face. It's either business pressure or skills, whatever you want to consider. Please stay on the same slide. Previous slide, please. Just stay on the slide, please. Thank you. The second is knowledge silos. Do you have experts in your organization who knows everything about the system? One day they are going to find another job. Then no one will know about that system. That's knowledge silos. Not to say that we do it purposely. We end up creating that kind of a situation for ourselves because we hate documentation. I am including myself. And documentation does not mean just typing a lot of things in one place. Sharing of information. Information is spread across the organization. Yeah, we do have problems in all of our organizations. We create knowledge silos. Because of that, sometimes we assume that someone knows something. It's called the curse of context. If I have done it, you can definitely do it. Then why to document? अभी आयुष ने बोल दिया हम बन गए थे. Okay? And then you have the third one, the complexity at scale. As your products grow, complexity creeps in. A very simple example for that is, as your products mature, a time comes when you start spending more time in fixing bugs than building features. Have you faced that? Raise your hands if you have faced that. Yeah. It shouldn't happen. But complexity brings its own challenges. Okay? As things grow, and obviously coupled with the knowledge silos and other things, problems creep in. Should we solve these? Anand, what do you think? Next slide, please.
We should definitely solve this, right? We must understand that end of the day, humans build software. We in this room build software, right? We have high expectations from the customer. Build fast. Jaldi jaldi deliver kar do. I come up with a requirement. I give one-liner problem statement. You just deliver it in no time, right? All of us have those expectations. The business wants it right here, right now. Everything is now. In an essence, on the business side, things are moving so fast. The competition is moving so fast, right?
Yes.
The business wants to stay ahead of the competition. Who is going to help them? Us, we, the developers in this room, are going to help them, enable them to deliver faster. We must admit that finding a good developer, a talented developer, is a costly affair. One, it is a difficult find. And two, all of us have become costly. Do you agree?
We should become costly. Agree to that.
We may not agree, but that's the fact. The IT has become a major cost center for most of the businesses. Right? End of the day, we are unhappy because we are getting to do more work. The business is unhappy because they have to pay us more, and we become a cost center. So it is important that we solve these problems right here, right now, and make sure that we become more productive. Next
slide, please. So now we know the problem. You want to solve it. A lot of the times, we solve it using anti-patterns. Here's one example. Doing more of something doesn't necessarily solve your problem. So if your project is delayed and if you add more people, 9 women make baby in 1 month. Nahi hota hai. Okay? Adding more people to a project that's already delivered doesn't help you. Adding more of anything in a given situation can actually bring in more problems than it solves. You have a problem of overflow all the time. But that's an anti-pattern that we have seen in most of the organizations. Haven't we? Okay. We spoke about silos, which means we should also talk about hero culture. We want experts in our organizations. We lack the expertise, and there's a difference. Expertise is spread across the organization. That's what everyone has. That's what everyone should focus on or target to get to. By having a hero culture, you end up creating another silo. One day the hero leaves. And finally, we are all yes people. Whether we like it or not, saying no is difficult. What happens when we say yes? What happens when we say yes? We get more of what we want. So take a very easy example of saying yes. If a tool can solve your problem, you should buy that tool? No, not necessarily. Think about the other things that you already have existing that can solve it before purchasing something. Saying yes to everything doesn't necessarily solve problems. Having said that, these 3 things are common patterns of solving problems. The challenges that we see, we usually go through it. At this point of time, we have gone through 3 slides. If you have faced this in your organizations, since he said that your voice should go till the first, cheer out loudly. Oh, you haven't? Okay, 1, 2, 3. Okay. Once more. 1, 2, 3. Chalo, good presentation so far. So Anand, what should we do next?
All right.
Next slide, please.
We should definitely think of solving this problem, right? There has to be a better way. There has to be a win-win situation where the business is winning, the users is winning, the customer is winning, and as a team, we are also winning. Most of the time, business is a priority, customer is a priority, user is a priority. Where is the team? Where are us who takes care of everyone? Who is going to take care of us? We in this room are going to take care of us. So let's see how do we solve this problem.
So if you go on the next slide, what we'll define for you is an engineering intelligence platform. Next slide, please. It says it's a platform that enables data-driven intelligence, leading to improvement in your productivity, better experience for developers, efficiency, predictability, every LET that you can think about. But it's too much to read, so if you can summarize quickly. Next slide, please.
Just to summarize, drive better engineering outcomes through data. Most of the things that we want to improve has to be driven by data. If you want to increase your revenue, data. If you want to increase productivity, data, right? And use these metrics to improve the time to market and better developer productivity.
And I know that developer productivity is a topic that all of us like. We enjoy speaking about it. We'll speak more about it. Okay? If you can go on the next slide, please.
How many of us have been to those meetings which talks about, let's do things faster, let's improve our velocity?
Velocity improvement is easy. The story that is 5 is 8 from today.
That's my standard answer.
Yeah, if you have not tried it yet, try it. It works.
Yeah, we can go 5x faster.
Okay, so there are essentially 4 categories that you should remember when we speak about data or metrics, okay? There is definitely the delivery metrics that we speak about. DORA, for example, the 4 key metrics, that's something that I'm assuming that we are aware of. If not, please go and check about it. That's about delivery metrics. But along with that, there are other types of metrics that you can utilize in order to achieve the results that you want. And we'll showcase how you can do that. Just to go through the remaining 3 categories, there is the quality metrics that talk about everything from a quality or standards perspective that we spoke about, code coverage, build failure rate, the tech debt, the amount of tech debt that you fix and stuff like that. There is the developer experience metrics that you should capture if you do not. Happiness index is my favorite. But then there are others as well where you can think about what's your review cycle time and other things. We'll speak about that as well. And then the operational metrics, which basically talk about, let's say, what is the cloud cost that you are spending per customer. Because that's also something that leads to efficiencies. So in short, you can categorize your metrics into these 4. And we'll go through a few examples just to see how that affects not just the engineering teams, but the customers and the business as well. All right? Can I have the next slide, please?
The key here is to not only measure those metrics which Vishal spoke about, but how do we connect it to the business outcome? End of the day, it should yield some result. It should not be that we are measuring something and nobody is getting benefit out of it. Right? So let's take some examples. Next slide.
Next slide.
Faster delivery, the favorite topic. How do we deliver faster? Focus on your delivery and quality metrics, right? If you measure your DORA metrics, code complexity, if your code is simple, you'll be able to deliver faster. If your test coverage is high, in a right way, not just lines of code coverage, but if your test suite is good, then you'll be able to deliver faster. Your testing time will reduce. If your build and deploy time is lower, you can deliver faster. Next slide. Reduce cost. Many a times as developers, we forget about the cost. We get an AWS account and let's go and spin up some servers. Let's try everything which is there. Let's try the new shining tool, right? But focus on those metrics as well. Focus, to reduce cost, focus on delivery and operations metrics. DORA metrics, again, classical one. Cloud per customer, cloud cost per customer. It is easy to add a new product, pay for it, but it is equally important to see what is the return of investment that we are getting from that product or a service. SRE metrics, the SLAs and SLOs and whatnot. All this would lead to the reduced cost and better experience for all the 4 stakeholders that we spoke about. Next slide. Better predictability in terms of how do we release the software, right? So focus on your quality metrics and DevX metrics. Code quality, if the code quality is high, you'll be much more comfortable releasing the software at production. Build times are low, failure rates are low, you'll be much more confident to release the next time. Every time you release, something breaks, it'll make you uncomfortable to release it next time. Code review time. You raised a PR 1 month ago, nobody has merged it, suddenly it becomes a priority, you merge it, and then pray to God that everything should work. Right? Developer happiness index. If we are happy, things will move much more faster, much more efficient, and things will be more predictable. Next slide.
So these are just a bunch of metrics, right? Ultimately, when it comes to transparency, we all want transparency in our organizations. You want transparency? How does transparency come in? It's my favorite question. To bring in transparency, there's only one way to do it. You need artifacts. Artifacts where you can see these things. Only when you can see these things can you do something about it. That is how you bring in transparency. So there are 3 basic components when it comes to engineering intelligence, where you want to look at some artifact that actually brings in that transparency that you're looking for. You need to have some delivery hub, places where the developers, the team can see the golden path that goes from dev till production. You need some kind of service hub, places where reusability becomes easy enough that you don't have to think about where you're going to find your next piece of solution. And then obviously the knowledge hub that brings everything together. These 3 are like your core components when it comes to building an engineering intelligence platform. All right? Can you go on the next slide, please? Here are just a few examples that you have, which are available in the market. Go and buy these.
All of them?
All of them. No, okay, yeah, please don't buy this, because then you'll end up doing more of what you want. But these are good software that you can utilize in order to improve your intelligence. Having said that, can you go on the next slide, please? You can start building intelligence in pockets. The idea is to find your constraint and then exploit it as much as possible. To give you an example as to how do you do that, all right, before you go and buy some tool. Can I have the next slide, please? Think about a very simple flow or a process, however you want to call it. You want to identify expectations from 4 different areas. You want to get it from the business, you want to get it from the customer is who's actually paying you. You want to get the user who may not be paying you but is using your services or products. And finally, the team, which in most of the cases gets left out. And the expectations has to be something that gives some benefits to the business. So business outcomes. Once you have these expectations, each of these expectations usually come attached with a OKR, KRA, KPI, choose your poison. I don't have any specific liking towards any. But each of these have some metrics that directly give you the information. Find those engineering metrics that are aligned to the KRAs that you have of the business objectives. And once you have that, you first need a baseline. A baseline is what do you have today, which in most of the cases might be 0. And that's okay. 0 is still a number. What you want to do next is have a target for yourself. What do you want this metric to be in 6 months? Or a quarter, or half year, full year, whatever you want to consider. And then work towards that. That's how the data that you're capturing and then through transparency you are looking at it helps you improve your engineering practices. ultimately everything that you do with these engineering metrics, because it's linked back to the business outcomes, your business gets the benefits of it. That can be as simple as how long is your downtime. That definitely is something that the business wants to improve. So that's something that you need to track. And once you have that, go in a continuous cycle. That's what we always say, right? Continuous improvement. So if you do want to do it, very simple framework, go ahead and try it out, right? Can I have the next slide, please?
As Vishal said, don't buy those tools which were presented yet. Where do we get started? We already have tools wherein we can get started right away. All of us use GitLab, GitHub, some SCM tool. Yes. We can easily do code commit analysis. We can easily do code review cycle time. We can easily do the max PR count. We can keep check of all of those things. Those are important metrics to track, right? Number of commits per day per developer, so that the code gets continuously merged with the main line. Number of open PRs, not more than one. How many of you have open PRs in your projects in double digits? Double digits?
Don't raise your hands for these things.
It hurts. So yeah, we can start all these with the tools that we are using right now. We don't have to go buy expensive tools. Project management tool, Jira, Trello. All of us use some or the other project management tool. All of them comes with plugins to give you the ticket resolution time, to give you the code review cycle time, to give you the production incidences, the bug categorization, and so on. You can easily derive some of the important metrics and keep tracking those. Things like how much time does it take from dev to production? Is it under 20 minutes? Is it more than that? If it goes more than that, it's a problem. Limit your work in progress, right? How many of us use some sort of continuous integration and continuous delivery tool? GitLab CI, GitHub Actions, Circle CI, something or the other, right? All of them comes with some important metrics to offer, to let you the failure rate. How many times the build failed? How many times we are releasing to the production? How many times have we rolled back? All of these are important metrics to track, because if we don't track them, we lose some important insight. Something is wrong in the delivery if things are not sailing smooth. And we need to identify why that is not happening and then fix those.
How many of you have more than one feature branches? You have more, don't raise your hands. Okay, I'm kidding. Next slide, please. Now, given that you can start with these because you have access to these, right? There are some things that you should be aware of, some common pitfalls. These are not individual metrics. You don't do performance appraisals for these. Even if you take velocity, for example, which may be a bad metric to have, I'm saying bad, but with a cherry on top, these are team-level metrics. Keep it with the team. Because there's some collective metrics that you're gathering which is transparent to the entire team to take care of. At the same time, these can't be compared across two teams. What you want to do is some kind of trend analysis, where your team was 6 months back with regards to their productivity, their efficiency, whatever you're tracking, versus where you are now and how that has impacted the business. And finally, don't overload one metric with more than one definitions. What happens because of that is, when that metric fails, you would get confused as to what do you want to fix. Okay? If your build time is longer than 10 minutes, and if your definition for that is you have a lot more, your test pyramid is inverted versus your code is very complex. If you have two definitions, you don't know what to fix. Have one definition for your metric. Okay, Okay, don't overload it for too many things. And as long as you take care of that, you're pretty much sorted. Whatever we have spoken over here today is for you to take the first step towards intelligence. Obviously, there's a lot more of metrics and a lot more of intelligence that can be built in, and you have tools to go and buy. Don't. Not now, not yet. But that's pretty much the gist of what we want to leave you with. So just to summarize, if I can have the last slide, please. Last slide, please. Thank you.